Okay, so previously I had solved an application using an OD5000 that I had a stack of parts like what you see here, and in this case it's a stack of washers. And I used the OD5000 to measure with an optical sensor how many parts had been taken off, or how many parts remained in the stack. So this is a demonstration of the same application but using an IMC inductive instead. So the IMC is an inductive that has IO-Link in it, so it makes it a smart sensor, smart inductive sensor. So as I move the metal underneath the sensor, you can see that the distance, it's actually a unitless measure. It doesn't give you an actual distance, but it does change the signal does change based on how much metal is in front of it, or how far away the metal is, or what type of metal it is. So using this, I can go into the detection tab and I can set up different outputs. So I have 4 different outputs that I can play with, and I'm going to go ahead and hit the eyeball to open those up, and I've set all of them to window mode. You can change it to single point or 2-point, but for this demonstration I'll do window mode. So I'm just gonna, since I only have 4 outputs, I'm just gonna show the difference in 4 different washers. So if I place this directly underneath, I have a little hard stop here that I'm going to try to keep there to make sure I'm placing them in the same spot. So looking at this though, here's my level for all washers full. So I'll just call, there are 15 in the stack, so I'll say with 15 washers, here's my level. And then I can literally just click and drag and create a window for Q1. So as long as that value is in this window, QInt1 is on. So I'll pull this out. I'll take a washer off the top. I'll try to put it back in the same spot. And you can see clearly now there is a good difference in the two. So I'll make this QInt2. So if I'm in that window, QInt2 is on. I'll do the same for 3 washers gone. There's my QInt3. I'll move QInt4 out of the way for now. There's my QInt3. Take another washer off. And here's my QInt4. So if I'm using this over IO-Link, yes, I could set up these individual outputs, or I could just send the distance data in unitless digits. I could send this distance data to IO-Link and create my own windows on the PLC. But you can clearly see now with 4 washers missing, QInt4 is on. So add another washer, put it in the same spot. QInt3 should come on. Add another washer. QInt2. And I might have said that wrong, but here is the 15th washer, and QInt1 is on. So with the IO-Link chip in it, the IMC sensor really does distinguish pretty well again how many of these parts are underneath it and at any given time. Looks like it's a pretty easy difference to be able to tell. So I can set up these outputs, or again over IO-Link I can send that distance data and create my own windows. So it looks like, and I gotta make sure I put it in the right spot every time for it to hit that window. So as long as the IMC is positioned correctly and it doesn't move too much, it can move a little, it just depends on how big your window is, but as long as it's positioned correctly and you can get it close enough to where whatever span you're trying to monitor, you know, for this it doesn't have enough range to see all of these washers, but if you're trying to detect really thin metal parts, and the full span of those parts falls within the sensing range of this sensor. Now the one I have here is the INC 30. It's an M30 housing, and it has a sensing range of 0 to 20 millimeters, best case scenario. So as long as it falls within the sensing range of that sensor, this could be a really good option and a much less expensive option to do this type of application than using an OD5000. So let us know if you have any questions.